So now that we know a little bit about how odds are calculated, let's look at the relationship between probability and odds in a few examples. So in this example, what is the probability of drawing an ace from an ordinary 52 card deck? Alright, so we're looking for the probability of drawing an ace. So let's review that initial notation. So the probability of an ace. Alright, so when you're doing the probability, the denominator is going to be the total number of outcomes in your sample space. So there are 52 cards total in the sample space. Out of those 52, how many of them satisfy the criteria about being an ace? That'll be 4 of them. So the probability of drawing an ace would be 4 out of 52, which then simplifies to 1 out of 13. Right, so that's probability. Now let's take it to odds. What are the odds of drawing an ace from an ordinary 52 card deck? Now notice that this says odds of instead of odds in favor. Those two things mean the same thing. So if I want to find the odds of drawing an ace, so the odds of, we would list the favorable outcomes to the unfavorable outcomes. So in this case, it's going to be the number of ways we can get an ace. So there are 4 ways we can get an ace, to the number of ways we don't get an ace. So out of a 52 card deck, how many of the cards are not aces? Well, there'll be 48 of them. So that'll be the odds of drawing an ace. It'll be 4 to 48, which then this can be simplified. Both of these numbers are divisible by 4, so this would be then 1 to 12. Now I want you to notice right here, the 4 to 48, if you add those numbers up, note that they will add to the number of elements in your sample space, which is 52. So you've accounted for all of the cards either being an ace or not being an ace. And then also notice in the simplified example, if you were to add those numbers up, they add to the denominator in your simplified fraction. Now if I want to find the odds against drawing an ace, because it's odds against, you're going to list the unfavorable outcomes first, and then your favorable outcomes second. Okay, so that'll be what we found, but in reverse. So the number of ways we don't have an ace in a deck of cards, there's 48 ways we don't have an ace, and there are 4 ways that we do, which would then simplify to 12 to 1. Okay, so in this example, we have a probability, and then we took it to either odds of or odds against. Now let's take this in reverse. Let's give you odds and ask you to find probability. So if the odds against an event are 26 to 1, we're going to find the probability the event occurs and the probability that the event does not occur. Now because it's odds against means you're going to list the number of ways your event does not occur, or the unfavorable outcomes first. And then you're going to list the favorable outcomes second. So in this example, there are 26 ways your event does not occur, and apparently 1 way your event does occur. So if I want to find the probability of your event, now probability will list the number of ways your event occurs, which we can think about that being the favorable outcomes, okay, the ones that satisfy your event, and then the denominator is the total number of outcomes in your sample space. Alright, so if the odds against the event are 26 to 1, that means there's 1 way that your event occurs. Okay, that would be the number of favorable outcomes, and then the total number of outcomes in your sample space would be 27. So we would add these two numbers together to build that denominator. Now what's the probability that event E does not occur? Well, we can use the idea from the previous section that the probability that the event does not occur would be 1 minus the probability the event does occur. Okay, that's one way we could compute this, because we have this probability. So we could say then the probability does not occur would be 1 minus 1 over 27, which would be 26 over 27. But to connect it to the odds, the probability that the event does not occur, that would be the unfavorable outcomes to the total. So there's two different ways of thinking about it. This way connects it back to the number that we're seeing right here. This way connects it to something that we had learned in the previous section. Okay. In either case, you get the probability that the event does not occur. It would be 26/27. All right, a final example then connecting probability to odds. Assume a free throw shooter makes a shot with probability of 88%. Given that, we're going to find the odds in favor of this player making his next free throw and the odds against the player making his next free throw. Now, 88% means then, out of 100 shots, we would expect him to make 88 of them. So 88%, this is the number of ways that the event happens to the total. Okay. So there's another way that we can compute odds in favor. You can compute this by saying the odds in favor is equal to the probability that your event occurs to the probability that your event does not occur. Okay, so we can actually use probabilities as opposed to counts, which is a slightly different approach, but we'll actually end up with the same answer. So I just want to show you what it would look like to use the probabilities. So for the probabilities, we're going to use the fraction form of it as opposed to the percent. So in this case, the probability that the event occurs would be 88/100, which would be the representative of 88%. Okay, that builds my numerator. Then the probability that the event does not occur. Okay, well, if there's an 88% chance that the shooter makes his shot, then the probability he does not make his shot would be 12%. Remember, the probabilities need to add to 1 or to 100%. Okay, so there would be a 12% chance he does not make his shot. 12% then as a fraction would be 12/100. So that would be then the probability that the event does not occur. So cleaning this up, this is fraction division. So this would be then this fraction divided by that fraction. So remember, to divide fractions, the first fraction stays, and then we're going to multiply by the reciprocal of the second fraction. We're going to get some nice simplifying along the diagonals here. So then this would simplify to this. Now in this case, when you're computing odds and you have it in a fraction, you don't convert it to a mixed number. So like for instance, this is improper, right? The numerator is bigger than the denominator, but we don't worry about that when we're doing probabilities and odds. So in this case, then for the odds in favor, the odds in favor we would report as 88/12, which then simplifies then to 22/3. So because 4 goes into both of those. So the odds in favor of this player making his next free throw would be this. Alright, so this is a little bit more complicated because you've got some fractions in there and you've got some fraction operations, but it is one approach that you could take. Another way that you can argue this is you could say, okay, if a free throw shooter makes a shot with probability 88%, that means out of 100 shots, he's going to make 88 of them and miss 12. Make 88 of them and miss 12. And so then that just gives you your two counts right there. And you don't necessarily need to mess around with all this fraction stuff. But this is another way to compute odds if you're given probabilities. And it will get you the same result. You just need to know how to take this final fraction and bring it back into writing it as a ratio using this colon. So odds against the player making his next free throw. So if it's odds against, remember you're going to list the unfavorable outcomes first. So odds against making his next free throw, there are 12 ways he would miss the shot. to 88 ways he would make the shot, again out of 100 shots total, and then this would then simplify to 3 to 22. You can also do odds against in a very similar format for how we did it over here. So odds against, just to kind of show you what that would look like. You would do the probability that the event does not occur. In your numerator, and then you would do the probability that your event occurs in your denominator. So in this particular case, the probability that you did not make the free throw would be 12 out of 100, or 12%. The probability that he makes this free throw would be 88 out of 100, or 88%. And then again, if you ran through this very similar process, you would get the final fraction 12 to 88, which then you pull that out, you would list that numerator first, then you would use the colon or the word 2, and then that number next. Just remember your final answer should always involve the colon.